before you do it, coming from somewhere. Okay? So iris give 5, 8, and then M. Yeah. M is equal to, you can make it new cluster is equal to M. Okay. Guys, are you there?
Yes, please.
Okay. So what I was saying earlier on was that, Melody, you can put your hand down once your stuff is sorted. Okay. So I said that once we've created this, let's go and add these clusters to our iris new data set. Okay. So let's see how we can go about it. So our cluster, did it work? Okay, so our cluster.
Or it is wrong to say otherwise.
Our
Let
class.
Our judgments, our decisions.
Okay.
Let not our judgment and decisions be based on personal beliefs and biases and prejudices.
Kindly put off your microphone, okay?
However, we should also be independent. You shouldn't be forced to do
just a minute, Christian, I'll be with you. So,
employees shall exercise independent judgment.
Please, kindly put off your microphone. I don't know who's
your
Melody,
Melody, can you put off your microphone?
Yeah, Melody.
Okay. So the cluster gives us the cluster points. Okay, so what we want to do is to go and add this to our cluster. So let's name this clusters. Okay. Let's, Christiana, just a minute, okay? I'll be with you. Just a minute. Okay. Let's run this. Okay, so now we go to iris new. Iris new. Let's pipe that. Let's pipe that into mutate. Okay. And then clusters is equal to clusters. Okay. The classes that we've created. Clusters is equal to clusters. And then what should we call this? What do you suggest? Fresh iris or cluster iris. Okay. Let's call this cluster iris. Or let's put everything together. Cluster iris. So let's run this. Okay. So now when we call cluster iris, okay, let me reduce this a bit. Let me call it again. So you see now, here what we've done for each of the observations, it tells us the classes that they belong to. All right. So for the first one, with sepal length 5.1, sepal with 3.5, petal length, and then petal width, they belong to cluster 4. Does it make sense? Okay. So we can now go on and even filter for cluster 4 and then do some visualizations out of it, you know, to get deeper insight into the data. Yes, Christiana. Christiana, please, you had raised up your hand.
Please, sir.
Yes, sir.
Before we... Yes, please.
Hello?
Please, can you hear me? Before when I run it, your figure is different from mine. Last week, the same thing happened. Hello?
Okay. Which figure?
where is it cluster underscore K $ cluster? The last one before we start.
Okay, share your screen. Let me see. Oh, are you using this? Okay. Okay, so just a minute. Just give us 1 minute, okay?
All right, sir.
Share your screen. Christina, share your screen for 1 minute.
Okay. Please, sir, can you see here the console?
Okay. What do you have?
Console. The console.
Yes.
The figures here, where my cursor is different from yours.
How do you know?
Won't it affect maybe the output of the answer or the outcome of the answer?
No, you have created 4 clusters, isn't it? The random numbers that you generated are different from mine. Okay, go up in the editor. Okay, go up a bit. Go up. Line 21. Okay. Have you said you created random uniform numbers of 50 each? Yours is different from mine. Okay, because these figures are random. So don't worry. That's why you are.
Okay.
Okay. All right.
Thank you, sir.
You're welcome. I'm giving praise, yes.
Okay. Sir, please, can you see my
Yes.
screen?
Yeah. So what's the problem?
Please, with the last part, I'm getting error in the mutate, and I can't figure it out.
Okay.
Yes, please.
Okay, so run the line 54. Let me see something. Yeah. So 56. That's running fine. Okay, did you call the library for deep learning? Did you run it? Run line 43.
I called it.
Now come back to line 58.
58.
Okay, so let's see. Clusters is go to clusters. Okay. Okay, so run it again. Yes, so you didn't run the library for deep learning. So run line 60 again. Line 60. No, not 59.
Okay.
We should run now. Yeah?
Okay. Yes. Sir.
Yeah.
Sir, please, thank you. Sir, please, what?
So let's give ourselves some few moments and then let's sort everybody out there. Then we can go for a break. I wanted us to do the optimal level of clusters, but I think probably when we come back from break, then we'll and then you give me the name and okay, so one and one line. Okay. So now you want to use underscore one. So I will type in so n equal to n. Oh, but you can use classes for and then classes will come. Which are you all okay? My ladies at the back. Okay, I'm a British. Okay. Great. So now we have some gurus in the house. The way you guys are, you can tell. Now we have some faster ninjas. Oh, but that's good. That's good. Now when we say something. Remember, this is just your third week. Can you imagine this now? Kind of okay. When do you want them to go for free? When do you want them to go for free? Teachers are they are giving serious systems. Okay. So any question? If no question, probably let's go for a break.
Yeah, break time.
So we come back to 1 hour, yeah? Is it 1 hour? Hey.
Yeah, 1.
Okay. How about on the timetable? Is it 1 hour? It's not 30 minutes. You people.
No, for the second one.
Okay, so let's go for, because we'll go for another one. So let's go for 45 minutes. Yeah. So let's come back. Let's come back at 2. Okay. Let's come back at 2. And then we'll go for another 15 or 20 minutes before we finish. Yeah. Because if it's too long, by the time you come, you'll be sleeping. Okay. Okay, guys, so let's go for break. Meanwhile, I'm here, so if you want me to explain anything, I'm glad to do that.
Please, sir, my hand is up.
Oh, Christiana, sorry, I didn't see. Yes.
Please let them go for break. Let me ask you a question.
You want to hijack me for the break? No problem, no problem. Yes. What is the issue?
Please, can you explain the graph, the plot, what we've plotted for the mutation?
Yes,
you
okay.
explain
So
it to me?
what we did was that the initial iris data, you remember it had species, and then we removed the species from it. Okay. So after we've created our k-means, okay, we specified that we wanted 4 clusters. Line 38. Have you seen it?
Yes, sir.
So when we created the 4 clusters, when you click on class $ cluster, okay, like this, it tells you the data points and the clusters which belong to the several data points. But this on its own doesn't tell you much. Okay, it's just telling us the clusters. Okay, so unless we add it to the original data where we will see each data point and the cluster they belong to, this will not make sense. All right, so that is why we. You say?
Can I ask a question? The 4, the new the Irish, is it Irish.-name? The 4,
Yes.
is it for a specific purpose or is that when you want to?
The 4, this one.
Yes, sir.
The 4 is the number of clusters.
Okay.
So the k-means algorithm, if you like, go to help. If you go to help here, okay, if you click on k-means, it gives you more explanation. Okay, so
For
you
the
can.
k-means, I understand it, but the 4 for the clusters, that was what
I'm trying to explain it to you that the k-means, the algorithm takes this argument. It takes the name of the data, okay, and then it takes the number of clusters that you want to create. So the 4 is the number of clusters. Okay? The 4 is the number of clusters that you want to create. All right? So that's why we use the 4.
All right, sir.
Okay. That's why we use the
I understand.
4. Okay. All right.
So the graph, sir, when it comes to the graph.
So the graph, this one, we've not used it, we have not used the animated to create the graph. Okay, but this was the graph we created for 2 clusters. Okay, so if we want, we can use the animation. Okay, we can use the animation to plot the clusters for this one too. So just give me a minute. So that one too, let's use cluster Annie. Okay, so class underscore Annie. Okay, it's the same thing as this one, but this one doesn't give you the visuals. Okay, so let's use k-means dot Annie. This time around we use k-means dot Annie. Okay, and then we say iris new. Iris new, and then 4 clusters. Okay, so let's run it. So that is going to give us 4 different clusters. So you see that it has started the iteration.
Okay. So it's giving us 2 different graphs.
Yeah, so
Wow.
this one, no, the first graph didn't belong to the iris data set. Please, the first graph belong to the random numbers we picked.
Okay.
Okay.
This, and if you are putting it in a more practical term, that's where you really get the understanding.
Yes, but the practical is what I've just shown you here on the
Yes.
graph. So now that we are done, okay, now that we are done, you see that it has 4 main clusters, okay, visually. So if you want to see where each cluster belongs to, okay, that's why we created from line 47 to 49. We use the iris new, and then we mutated by adding a new column, okay? And then we said that this clusters, this one gives us what we have here, the number of clusters. We just named it clusters. So when we named the clusters, we mutated and came and added the clusters. We created a new column called clusters, and then we brought in the clusters that gives us the number of clusters. Now, when you run this, what it's going to do is that it will add a different column. Okay, so now let me reduce this a bit and run it again. When you run this, you see that now it has given us, apart from the information that was there already, let me go up a bit. Apart from the information, you know, this wasn't there. This classes wasn't there.
Yes.
Okay, So now this makes sense. When you take one observation, you will know which cluster it belongs to.
Yes.
Okay, And then now, based upon your knowledge that you have in deep learning, you can even filter for particular clusters you are interested in, and then do other visualizations or other insights that you want to get from the data. Okay.
Thank you very much, sir.
You're welcome.
Well, I realized one thing during the week.
Yeah.
Is it that there's every data in the program you need to use, or maybe with this data? Is it every data set is designed for a particular program, like maybe R? You have a data set like the telco or the one at the glossary. It's purposely for R.
No. It depends upon your data. So your data will determine the kind of visualizations or the things you can do with the data. I can use telco in Python. or SPSS or any other place.
And we can get the same answers, maybe the same questions with the same answers.
Yes, but you know, the kind of things R does probably SPSS cannot do. Okay.
Okay.
Both R and Python, basically they do the same thing, but Python is much more, it has much more broader use, whilst R masters in machine learning and then statistics. So each programming language and its strong points and weaknesses. Okay.
Thank you,
so
sir.
you can do the same thing in Python and get the same results.
It depends on what you're actually looking for or how you want to use it.
Exactly.
Thank you very much. So
You're
I'm very
welcome.
grateful for getting for having the patience for me.
Don't worry. That's why we are here. Okay.
But still, it didn't work. Oh, last week when I ran it, when I came home, spent some time, still didn't run. See,
When you ran what?
You see, last week I asked a question. I told you we did something, we ran it, and mine did only gave me the headings.
Oh, okay. Well,
Yes,
we'll have a look at it again. Okay.
All right.
When we finish, probably during the week. Just give me a call and then we'll go through it again.
All right, sir. Thank you very much.
Okay.
Hello, Nana.
Yes, Abigail.
Please, I want to share my screen. So.
Okay, Abby, please go ahead.
Oh. Mm. Mm. Now, please, can you see it?
Yes, I can see it.
Please, when I ran the KM cluster from there, I didn't get what you got, like, which was in the form of like a diagram. Like, I didn't get it. I don't know why.
Okay. So run 32. Let me see something.
Okay.
Line 32. Oh, you don't need to highlight it. Just put the cursor there, run. Okay, so it's running good. Okay. So
33.2.
33.2 is working, isn't it? Run it.
Yes, please.
Good. And then sentence. Good. Okay. So let's see the animation. Have you called it from the library? Run line 29 again. Good. Okay. So now let's come to KMA using animation. So run it. Click on there and then run it. Yes, so it's running. So you see, when you come to where the quadrant on your right hand side, click on plot. You've opened the packages tab. Click on plot. Yeah.
Okay. Mama. And then also, when I got the mutate parts, when I run this, it's not coming.
Okay. Did you call dplyr from the library?
Yes, please.
From the library. Where is it? Run it. Okay. Run the glimpse. Yeah. Run the glimpse. Yeah. Okay. So run everything again. Run everything again and remove the species. Run line 50.
50.
Okay. So run everything. Run everything.
From 51.
Yeah. Just continue.
Okay.
Okay. So now we are good. So come back to, okay. So now come to line 59.
Okay.
Line 59. Okay. So now you can run line 61. It should work now. Yeah. And then call it. Yes. Run it.
Okay.
Yeah.
Thank you.
You're welcome. Yeah.
See the iron. If you want to practice, like apart from the thing.
Yeah, go to W3 schools. It's a website. I mean, there are so many tutorials. Okay. And so it teaches you what to do. And be watching videos too. Okay. That's how you learn.
That's why I'm asking you that. Where the
Oh no, go to Kego. Kego, you
Yes.
know Kego, GitHub.
Yes.
Yeah. There are so many data sets there. Okay. So sometimes when you go there, they have topics and the kind of data, there are some data sets that are more suited for some topics. Yeah, so download and then look at the syntax people have developed. Try and run it, learn, ask questions, those kind of things. That's how you.
Because this association.
Oh, okay.
So that time,
At the workplace.
Yeah, that time I was not so much. When I watched them,
Okay.
when you explained it, I was able to understand very well because they did some for allied data. Yeah.
Oh, okay. Oh, okay. Where do you work?
It's a small startup, so somebody just got that.
Oh, okay.
That time I was actually doing the marketing. So data.
Oh.
So
you set up your own company now.
Yeah, I still work. It's a small startup. So right now we have registered. I'm actually the one doing that.
Oh.
If I'm
then you need to understand. Then
right now, my cousin and the other girl, they're all in the US. I'm thinking like, right now, if I can get a contract right now, I have to lead the discussion. They are all data. One is working in the insurance firm in the US. The other guy is working at the Novo.
Okay.
Supply chain analyst.
Oh, okay.
And my big brother is director of analytics at Shop.
Oh.
They are all data.
Oh, then please do. Then it will help you. So even if you happen to go to the US, finding a job will not be difficult. Then it's a good.
Because a lot of businesses, they don't want to.
It's just a matter of time. You see. Yeah, it's just a matter of
That's
time.
what I told one of my friends. It's better you prepare yourself and
position yourself. Yeah.
When the time comes.
Yeah. It's just a matter of time. Now people are getting to know about data science.
Well, now even on my LinkedIn, I've been receiving because of some of the things. I've been doing some Power BI, so I've been putting Power BI dashboards LinkedIn before even I start the course.
Okay.
So yes, I was telling the last time that right now that it's good thing that I'll be sending my dashboard and be reviewing it for me. And he said, okay, that's fine. And the past thing to say that I can share some of the dashboard because sometimes when the new features and things come, sometimes just go and see what I can do.
So you do it and then you put it on LinkedIn and then people get in touch.
Yeah.
They want to.
Somebody got in touch sometimes. Once that small, I cannot be. Okay. I just was a small, simple dashboard, and I told them that every time, make sure that I have this one.
Okay.
It's working for them.
Oh, okay.
So right now that I'm learning more, I'm doing more of this association. I can talk about category management.
Yeah.
I can talk about market basket analysis. I can advise them that this and this goes this way. That time when they were doing the thing, I was watching. I even have a template. That one they used Python.
Okay.
So this Python that looks very simple and concise.
Yeah.
Just thank you.
That's good. So let's see how things go.
Yeah, I'm just hoping that after this, use it to make some
money.
Because right now, Ghana, if you're not making it, I think we have. A lot of us want to you still have responsibility. You have to look for money. And before you can have a sound mind to learn. Right now, if you have a responsibility, you want to waste time and be learning fast, you have something.
Let's see how things go.
Are you taking us in the next block?
Yes, I'm taking for mathematical foundations.
And you still use R?
We will use R, but very limited. That one is just the maths. So
start the statistics
and
maybe the quantitative methods.
Yeah.
So that way we are doing that's good.
So that one
for Power BI because
not only Power BI, it gives you the next block I will be taking for predictive analytics. So
that's the thing. That thing.
It gives you the mathematical background to some of these things so that you understand it better. Yeah. Because
so the predictive analytics we do it in this semester.
No, next semester. This semester you do mathematical foundation. The next semester you do predictive. Because you need the maths for that.
Yeah, first will be taken as 5.
Is it?
First will be taken as 5.
I think so. Yeah.
The way the course structured the answer.
Yeah, that was the reason. The main idea for this, but it's not going to be theoretically based so much because people do data science and they cannot do anything.
Mostly, they say now it's good to have a portfolio as a data science person, not even only a data scientist. But if you want to demonstrate that you can, doesn't mean that we have to write a code and keep GitHub somewhere that you can maybe somebody wants to see what you can click or what is the first thing to do.
Oh, you see, the main thing is not about R or Python or SQL. The main thing is about results. If the company wants to do something, can you do it? You can do it using R, or you can use it because whether it is Python or R or SQL, what the company wants is output. I want this to be done. So if you can do it with R, fair enough. If you can use R Shiny to create dashboards, why not? Have you seen? So for me, as a data scientist, as much as possible, know your Python, SQL, and then your R. These 3, at least, will help you a lot. So the main thing is about getting into an environment. If it's a Python environment, you can survive. If it is a SQL environment, you can survive. If it is R environment, you can survive. So if you know these 3, most of the people use these 3. Okay. Then you add your visualization tools, that Power BI or Tableau, and you are good to go. So it's not really about showing you that I know how to use R. It's about the results. What do you want to do? If it's classroom, I can use R to do it. What is your issue? I've done the work. Have you seen? So take these courses seriously because it's not just about knowing the models, but being able to build it, from scratch. Okay? You can build a database or a data warehouse. How can you create a pipeline to import it into our environment or to import it? Because your data source, where are you going to get it from the web? Where you get it? Where will you store it? So all these things are important. Have you seen? So you've heard of data engineer. Okay, So the data engineer can do the job of a data scientist. Okay, and a data scientist can do the job of a data analyst, but not the other way around. So build yourself in such a way that end to end, you can function in all of them. So by the time you finish with this program, I know you'll be doing other stuff. You'll be able to handle all those issues.
Yeah, because for instance, if I want to, assuming I have a website, and I want to get the data of that website, like the clicks and all those,
yeah, so you go to Google Analytics to help you how to go about that. Okay, then finish, you pull it into your DFLA, off you go. And then you manipulate it, you can do your visualizations and stuff like that. Everything. Yeah, so you know the number of people who visited your website, you have the graphs to show the clicks and what are the things that are popular. You can bring in your ARUs to see how various things are connected. That will lead you to redesign your website. Yeah. Those kind of.
So that one, let's say I have a website and I want to get all the data. It means I have to go to
Google Analytics, yeah.
They will just give me the
data. Yeah, so you watch videos on that, how you can do that. Have you seen? And then, yeah, you can get all those details. They are important. The Euclidean, the football. Yeah. You people, you will not let me go for break. You want to hammer me to that.
I'm enjoying that and I'm enjoying the conversation.
You are getting the same thing.
Yes, for the one we did had 0.75 for 1 and 2, 0.75 for 1 and 2 and 3.
Yeah.
And then 0.6
something.
But for that one, I was still getting 0.75 when I did the normal count.
Oh, that's right.
Yeah. So I did. See, that one is the first one was true, false, true, false, true, false, true. Then the third option, that was for the first one we calculated. That's the A and B. Yeah. That was when we had the 0.7. So we calculated we found for the B, that was the true. That was when we had the 1 per hand.
1/4. Yeah.
The distance was the 0.7. But when we added the third one, that was the true, false. When you calculate for 1 and 2, that was this one. Then 2 and 3, we are getting that the B and C. The true is only for 1. That's the whiskey.
2 and 3.
Yeah. So I still had 1 over 4. That's the 0.7. But when you check yours, the 1 and 3.
That one was 2. Was it 2?
That was 1 and 3.
Let's see.
Because if it was 2,
I need to check it out. Let me see if I can. Oh, this the K-means. Oh yeah, so we can still use this. This one.
Yeah, this one.
So 1 and 3. So let's see 1 and 3. 1 and 3 we have true, false, false, true.
False. So it's 2.
That's what I was asking. If false is also.
Yes, it is.
So where is false?
The last one.
False.
That's why I think we are using only true, or we need false to look at that as true.
Yes, but even if you do that, even if you do that, it's going to give you 2/4, and that's half. So that's not it. But this one is correct. That's what this one is correct. So we need to find out what happened.
Maybe the data that was used here.
Let me see. It's the same thing because this one was named survey. Okay.
Or the union has changed in that regard.
No, it's 2 at a time, isn't it? So one. For here, it's 2 false. For whiskey, it's false true. And then for vodka, it's false. Oh, I think that was when you were asking the question. No, somebody made a comment in Kumasi, and it's true. Now, when the false, it disregards that. Okay. So that's why you're having 2/3 in this instance. Disregard that. And then 2/3. That's why it becomes 3. Yes, the union becomes 3. Okay. Yeah. All right. Okay.
这个就不干了，这就不干了。
Hello, Kumasi, are we ready?
Yes, sir.
Okay. Can I have another person confirm? Just in case 29 have gone on break.
Yes, sir, we are here.
You are there, okay. Are you on campus?
Yes, please, I am.
Oh, okay. All right. Okay. So I'm on loudspeaker. Am I on loudspeaker like last week?
Yes, sir.
Oh, okay. Okay.
Oh, no, not like last week. Yeah, individually. I'm just
Individually.
I
Okay.
just on campus.
Kumasi people, they are chilling, no? Yeah, yeah. They have a very beautiful place. Okay, guys. Let's continue. Accra people have gone on break. By the time they come, would have finished. Okay, so let's use the real estate valuation data set that I sent to you. So this practical example 3, yeah? Is it 3? I'm not really sure.
Yeah, this will be the third one.
This is the third one, yeah? Okay, so let's import our real estate data set. So another way by which you can import your data set, let me show it to you, is to
Please, you are currently sharing just the PowerPoint
oh, is that
presentation.
so? Okay.
Yeah.
All right. No. So when you set the working directory, then you tell R that everything that I'm doing, I'm taking it from this directory. So you don't need to set it again. If you haven't closed R, so everything that you import there, you just go ahead and read it. Is that okay? Unless it is somewhere else, then you have to change the working directory. Is that okay? So based upon that, since I have it already, so yes, and you brought in this, so the other one, okay. So what you do is that go to environment. Okay. Environment, import data set, have you seen? So click on there and then use the first one. So you can import from SPSS, SAS, data, and others, okay? No, use the first one, test based, okay? Then this dialog box will open. So navigate to where you have your data. Yes, we are using a real estate. So let me see where I have mine. Okay. I have mine here. Real estate. Open. Okay, so another box should open. Now, are you following? Now, sometimes you see what we did in the past. The categorical variables, when we imported it, we created factors. Okay, so we wrote a syntax for the factors. Okay, with this one, where there are categorical variables, you just check the factors dialog box here, string as factors. Have you seen this one? Yeah, but for now, just leave it as it is. Just leave it as it is. But for other ones that we'll be doing, if they are categorical variables, And then we are importing history. That means that when it comes, by the time it comes into R, it's already factors. Remember, these things that you are clicking is generating the code behind the scenes. All right. So it makes work easier. I really want to show you the easy one bit first. So you can just import, if you have categorical variables like the telco, for instance, you can just make a string a factor. So by the time it comes into the R Studio, it's already factored. Yeah. Okay. So we use that. So we want to want the heading, everything. Okay. So import. Okay. So see that it opens. It creates a view for you automatically. All right. And it opens it for you. So let me close this other stuff that I have here. So basically, what we have here is a data set for houses. Okay. So it's telling us the age of the house. The age of the house. We are using the real estate data set. So it's telling us the age of the house, the distance to the nearest train station, the number of convenience stores, latitude, longitude. Okay, so this is spatial data. Latitude, longitude, and then the house prices. Yeah. Okay.
Luna,
yes.
Can you please show me how you imported the data again?
Okay. All right. I will show you. Okay, so you go to, you see your environment, where you have your environment, the global environment. You see import data set. Yeah. Click on the arrow down there and then click on test base. If you are importing from Excel, then you use Excel. Okay. If you are importing from SPSS or Stata or any other, you do that accordingly. All right. So you click on base, a dialog box will open, and then navigate to where you have saved that data. Okay.
Okay.
When you locate it, click on open. So like this, open. Now it will open this import data set dialog box for you. All right.
Yes,
and
sir.
then I was explaining that we are not doing this now, but I was explaining that, remember the telco data set that we imported the last time? We created factors on the categorical variables. Do you remember?
Yes, Nana. Yeah.
Okay. So if you are using this route, you can click on strings as factors if you have categorical variables in your data set. When you check it and then import into R, by the time it comes into R, it is already factored. You don't need to write a code for factoring again, unless probably you want to change it and stuff like that. So it makes life easier. Okay. But for now, for this one, most of the stuff we'll be dealing with are numeric. So there's no need for factors. So don't check it. When we are done there, you import it. So when you import it, I was explaining earlier that whatever you are clicking is generating the syntax behind the scenes. So if you look in the console, have you seen that it has the one for import? Have you seen? It has read it, okay, straight away with the file path, and then it has viewed it. Have you seen the syntax in the console? All right, okay. So it has saved it as real estate valuation. Okay. But for our purposes, we just want to use rev. Okay. So let's rename it rev. Kindly put off your microphone. I don't know how many. Okay, I think this time around.
Side bagels then for this matter. I say, no, with this guy.
Let's name this
They allow them, please mute.
Okay. So let's run it now. So now the real estate valuation is named Rev. All right. So let's have the first few lines. Do you remember the syntax if you want to read the first few lines of a data set? Head, okay? Okay, so head, Rev, okay? Let's run it. Just to have a feel of what the data set entails. Okay, let me run it again. Okay, so it's giving us information on, we saw it in the view. It's giving us information on the house, the ages of the house, how the distance to the nearest train station, the number of convenience stores on the road, okay? The location, and also the price of the house, okay? So this is what we have. So what we want to do is to, we don't need the longitude, latitude. We are not doing spatial analytics at the moment. So let's remove the longitude, latitude from it, okay? So that we just concentrate on the other features we are interested in, okay? So dplyr, okay? So now, since you've turned on your R in the morning and then you called it from the library, there's no need. But supposing when you are going for break, you put off your R, then you need to call it from the library before it can work. Is that okay? So first of all, what we'll do is that let's select the features that we need. So let's call this Rev1. So we are taking it from the Rev. Is that not it? And then we pipe that to select. To select. So instead of typing the ones that we need, there are about 4 of them, why don't we type the 2 that we don't need? Okay, so minus latitude and then longitude, okay? Okay, so let's run this. So it's good practice to be commenting on your work so that when you go back to study, you can know what is happening. Okay, so let's comment here, selecting needed features, okay? So this is all part of what we call feature engineering, okay? You look at features and then you remove the ones you need, the ones you don't need, scaling and everything. They are all part of feature engineering. We'll have more about it when we are doing predictive analytics, okay? All right, so we've removed, have you run it? I don't think so. Let's run it. So now, let's have a glimpse of it. So now, we don't have latitude and longitude. Let's just confirm. So Rev1. Okay, so now we don't have longitude and then latitude. Any questions on this? Now, look at the glimpse, okay? The house ages, they are double digits, okay? Distance from house is, okay, double digits. Some of them are triple, okay? Look at the house prices. They are in thousands, okay? I think the first one is it 379,000. Okay. Now, though they are all numeric, okay, 379,032. I mean, when you are look at the age, the disparity in the numbers for the ages, and then also for the house prices. If we are to do some analysis, the disparity in the numbers are too huge. So in such a case, why don't you standardize all of them? So we need to rescale all the numbers so that they will all be manageable and be able to do proper comparison if we need to. Okay. So one of the reasons why we do normalization or standardization is that if now, okay, if all of them, let's say, are in, some of them are in different units, like kilograms and then meters, okay, then we have to do that to bring all of them to the same level, the same type of units when you normalize them so that we can compare. Or they could be in the same. Here we're talking about numbers. They could be the same, but there's huge disparity in the range of numbers. And that is what is happening here. So we need to find a way to rescale it, okay, so that we'll be able to do meaningful comparison as we go along. Okay? Because if you don't do this, and then there are huge figures in there, it's going to affect your mean. If you want to find the average for something, it's going to affect your mean. And, you know, if, let's say, one huge figure is there and the rest are small, it will affect the mean. The outlier will affect the mean, and all your analysis will not be relevant. Okay. Please, any question? You have a data set with a sales figure. Okay. Yeah. Yeah, small. So let's say you have unit sales, you have quantity, okay? You have selling price, okay? Those ones are linked. Okay, you both, because you have to multiply the unit price by the quantity in order to get the total. All right. But let's say apart from the selling price too, there is another feature about the product that is there. Let's say the age of the product. Okay, the age of the product, which is 3, 4, 5, 6. Okay, and then another feature of the product. Let's say, what else? So there can be various features of the product. Okay, as for multiplying this by that to get this, especially when you do principal component, you can just even remove the unit price and then the quantity, and then we have the price, the total, because that is what we are interested in. All right, but you can have other features of the same product. Let's say you have the total sales of the product, you have the age of the product. All right, okay, and then other features of the product, which might not be in the same units, for instance. All right, it might not be in the same unit. So you need to ensure that if that is the case, you need to ensure that you standardize it. All right. Or if even they are in the same units, but the numbers are too, then the range disparity is too huge, standardize it so that you'll be able to do meaningful comparison. Okay. So if you have numbers, you can't say that, okay, the way I'm looking at the numbers, I think these are huge. So let me scale it. Okay. You can use a mathematical way to find out whether you need to scale it or not. Remember, when you do the standardization, your mean should be 0 and then your standard deviation should be 1. When it is like that, then that means that, they are in a way that can be comparable. If it is not like that, then you need to rescale it to make it mean 0 and then the standard deviation 1. Is that okay? All right. So based upon what we have Rev 1, isn't it? So let's see if we can do some data transformation to it. First of all, let's check whether the mean is 0 and then the standard deviation is 1. Okay? Okay. So here you can just use normal R inbuilt co-means. So it's column means. So it will take each column and give you the mean. Okay? So we can use co-means to check on Rev 1. So this one gives you the mean, okay? Gives you the means across features, all right? Across features. Is that okay? So let's run this and see. So you see the means we are having. It's not 0. Okay. So we have 10.7. We have 1000.08. See this one, this plus 0.3. So if it is positive, then you add it to the front figure. If it is negative, that means it is a decimal. Is that okay? Please, you follow. All right. So the means tells you that these are not. So the mean has been checked. Let's check for the standard deviation. Okay. So we can use the normal apply. Let's apply Rev 1. And then let's check for two places. And then let's check for the standard deviation. So the standard deviation should give us 0. It is not 0. So that means we need to rescale it. Even with the mean wasn't 0, so we need to rescale it. Okay. So here, checks for standard deviation across features. Okay. So we need to do data transformation. Or rescaling. Okay. So we use the function scale. All right. Scale and then Rev 1. Do you remember the formula we used in the PowerPoint? The actual figure minus the mean divided by the standard deviation. So when we use the function scale, that is what it is doing. It's changing everything to a standardized format. Okay. So scale. All right. Let's name this Rev scale. Okay, so that whenever we are using it, we know that this one is the one that has been scaled. So let me make a comment here. So this one transforms data into standardized form. Yeah. So let's run scale. Okay. So it's running now. So let's check the co-means again and also the standard deviation and see if it will give us 0. All right. So let's just copy this co-means. So we change this to rev scale. Is that okay? We change this to rev scale. Let's run it and see. Am I getting this? Okay. That's strange. Okay. Let me do summary. Rev scale and see. But here, you see that the mean is 0 here. The mean is 0 here. I wonder why the other ones is not giving me. So here to house ages, you see that the mean is 0. Are you saying? Okay. Okay. Then let me get rid of this. So let's do the apply also and see if it will give us a standard deviation of. So this one we change to rev scale, yeah. So here you see that it's giving us a standard deviation of 1 for all of them. Okay. So mean is 0, standard deviation is 1. So that means, so mean is 0, standard deviation is 1. That means that it has been standardized. The rev scale has been standardized. I'm wondering why the poor means didn't. Let me check it again. Okay. Then the reason why it's giving that is, you see, we have 17 zeros ahead of it. It's virtually 0. It's e raised to the power negative 17. So we have 17 zeros, so it's virtually 0. Okay. This one to e negative 17. This one to e negative 16. Yeah? So it's virtually 0. All right. So now that we have standardized it, let's find the k-means. Okay, let's find the k-means for this. Because remember, let me make this point again. We are going to put everything into clusters. So that is why it's important that you need to standardize everything so that they become, the features become similar, so that when it's determined whether this point is nearer this point, it will be correct. Is that okay? All right, so let's do our k-means. If you want to use the animation, you can do that. Okay, so determine 4 clusters. So let's determine 4 clusters using k-means, yeah? All right. So here we use our ref scale. That's the one we've scaled. Our ref scale k-means is equal to k-means. Should we use the animation? K-means dot ani. Okay. Ref scale. And then we want to use 4 clusters. Okay. So let's run it. So it's iterating. So whilst it's doing all this, it's calculating the centroid and then the points within each cluster. Okay, like I explained earlier on. So it will stop as soon as it becomes stable. Okay. All right. So you see the 4 clusters there. Okay. Some are overlapping a bit into others. So let's see the centers. Okay. Let's see the centers of this cluster and then interpret it. Okay. So ref underscore scale km dollar clusters. Okay, so let's look at the centers. As for the clusters, we know there are 4 clusters. Okay, so let me reduce this a bit and then explain what we have here. I want everything to be in one. This distance. Okay, let me wrap this in view and see. Okay. Please, can you see my view? Can you see my view? Or it's not very legible?
No, it's very legible.
I think those here cannot see it. But when you run it, can you see it opens another tab? Okay, all right. So let's see. So the clusters. So we have cluster 1, cluster 2, cluster 3, cluster 4. Let's see what this means. So the first cluster, you see that it is negative, isn't it? Negative 2.3, positive 2.5, negative 0.7, and then negative 0.6. Remember that these are all standardized form. Okay, so how do we interpret this? So the house prices, the age of the house. The first cluster is that the first cluster consists of house prices, houses that are new. Okay, the age is low, so they are new houses. Okay, or the age is not very old. Okay. So we have, well, you can interpret it as low house age, okay? And the distance to the train station is long, it's positive, it's long. The number of convenience stores are few, it's negative. And then the house prices are low. Okay, don't worry, we'll come to that. But let's get the interpretation first. Okay, let's look at the second cluster. The house prices, the house ages are high, okay? Distance to the train station is low. Number of convenience shops are more. Therefore, the house prices are high. Have you seen? Is it making sense?
Yes, please, it is.
Yes, so if it's negative, put it into context. So if it is house prices and it is negative, that means that it is not old. It is a new house. It's not a very old house. It is a new house. If the nearest distance to the train station is negative, that means there's less distance to the train station. Okay? And then number of convenience shops is positive. That means you have more convenience shops. Okay? And then the house price. So, I mean, look at a house location where distance to the train station, it makes sense, isn't it? Distance to the train station is low. Okay? There are so many convenience shops around. Okay? And fine, the house prices are a bit old, but it's making it a prime area. Therefore, the price of the house is high. Yeah, the house is new. No, this one, I was talking about the second cluster. It's positive. So the house is old. So in spite of the fact that the house is old, but it is near the train station, so many convenience shops. So therefore, the price of the house is high. So that's one cluster. The third cluster is house. Please, put off your microphone. We've got a very important area. Okay. Please, can you tell the person to mute?
Greg, please mute. Greg.
Okay. So the third cluster is, who can explain the third cluster? The third cluster, what are the features of those in this cluster? The first value. But is there? Oh, you are not seeing. Okay. I wanted to. So it's negative 0.81. So the house is new. And then the distance is negative 0.6. It's close to the train station. Okay, less distance. Okay. And then convenience shops is positive. it's positive. There are more convenience shops. Okay, so the house price is high. It's positive. Okay. So you see the sense it's making now. Okay, what about the last one? Kumasi, can somebody answer the last cluster? Can somebody answer what is in the cluster?
Yes, dog.
Yeah.
The last cluster has a positive figure, meaning that the houses are relatively older, yet they are considerably close to train stations.
Is it close to the train station? It's positive.
Yes.
The train station is positive.
The train station is negative in mine.
Oh, it's negative in yours. Okay.
Yeah, negative 0.534.
Okay.
So the distance is
mine is positive 2.5. Okay, fine. So you interpret what you have.
Okay. But then there seems to be more convenience stores in that neighborhood. Yet the prices for the houses, though they are high, but they are not as high as the prices in the third cluster.
Okay, that's a good. So I think for ours, it has moved the clusters around, but I think it's the same number of clusters you are dealing with. Okay. Can somebody explain cluster 1 based upon what you have on your system? Based upon what you have. Yeah, okay. Kumasi, yeah, go ahead. Is somebody answering?
Yes,
cluster 1. Cluster 1, yeah.
For cluster 1, you see that the houses are younger. They are not very old. They are newer houses, but train stations are farther, at least compared to cluster 4 and 3.
Okay, so first of all, what you do is that mention what is in that cluster, and then we can do the comparisons later.
Yeah. All right, Doc. For cluster 1, the house age in years is negative 0.23. Meaning
the houses are fairly new.
They are fairly new. And then the distance to the stations is a positive figure, 0.25.
Okay.
Meaning the train stations are a bit farther.
So the distance is long.
The distances are long.
And
then the number of convenience stores I have is negative 0.7.
So less convenience shops.
There are less convenience stores in that neighborhood. But then the house prices is negative 0.63. Meaning house prices
the house prices are low.
Are lower, yes.
Cheaper. Okay. So you are realizing that it's like the distance to the train station and number of convenience stores are having an impact on the house prices more.
Yes, I'll say so, Doc. I believe so.
Yeah. Okay, so you see this kind of the insight we are getting from the data. Okay. All right. So if it was 5 clusters, it will put everything into classes, and then it will give you the characteristics of all of them. Okay. Okay, so based upon what I have here, let me just write it here. Based upon, so let me say insight from clusters, okay? So cluster 1, I would say that cluster 1, negative, I think I had a... So low house ages, for cluster 1, low house ages, more distance to cluster 1. Let me check from here. So it's more distance to the nearest train station. More distance to nearest train station. And then, let me see. Less convenience stores. And then less house or lower house prices. So you can look on this and then interpret the other clusters in your own work, okay? This is just to keep. All right. Any question? Okay, so somebody asked the question earlier on as to how do you determine the number of clusters? Okay, because with K means you tell it beforehand the number of clusters that you want to use. Okay. Sometimes there are some conventions. Sometimes people just take the number of data points you have and then they find the square root and then use that as their K. You can also use what we call the scree plot or the elbow plot. And it will give you an idea as to the optimal number of clusters to use in your K for the K means. Okay, yes, Nancy.
Yes, Doc. Maybe you said this, but perhaps I didn't catch it. But just to clarify, it's like what we are doing is taking all the observations in the data set we got, the real estate, and then it's kind of grouping it into 4 clusters and giving us the statistics on it. Is that correct?
Yes, so it's not really like the statistics, but it's giving us the features of the clusters.
Oh, the features of the clusters.
Yes.
Okay, so how do we know exactly which observations are within?
So you see that when if I use this, okay, so these are the number of clusters. We specify 4 clusters, didn't we? Please, are you following?
Yes, Doc, I'm following.
So we specify 4 clusters. So the first cluster is all the features of the first row describe the first cluster.
Okay.
Okay, all the features in the second row describe the second cluster, and so forth to the 4th cluster.
All right.
So so what we are saying in cluster 1 is that the basis for the groupings for this cluster is that it comprises house prices that are low.
That are low.
Distance to the train station that is long. Okay.
Yes.
Less convenience stores, and then less house prices. These are the features of cluster 1.
Okay.
So, for instance, if you want to do some kind of promotion, then you can identify those houses that are in cluster 1.
So that is my question.
Yeah.
Identifying those observations that fall into each cluster. Yes, that is my question.
That's very easy. Remember we did earlier on, we did this. We did let me see. Even we have ref scale here.
Yes.
Okay. See. We can just we also have ref scale $. It's ref scale KM, isn't it?
AM, yes. Ref scale KM.
$. So we have the cluster, okay?
Okay.
So we have the centers and then we have the cluster.
Okay.
So when you choose the cluster, it tells you these are the clusters 1 to 4.
Okay.
All right. So we can actually go and
so
add
each
this
observation is showing which cluster it's in.
Exactly. Okay.
So then you can just index it and it will show you more about that.
So we can use our normal dplyr to do that. Okay.
All right.
So let's say we take so let's take ref scale the original one, yeah. And then we pipe that into mutate. Okay. And then so this ref scale, let's name it what name do you want to give to it? Is it new cluster or cluster points?
Okay, let's make it cluster points.
Okay, cluster points. So cluster points is equal to this cluster. Okay, let's run it. So when we mutate, we can say that cluster points is equal to cluster points. Okay.
Okay.
Okay, so when we run this, it's mutate. Just a minute. So this one gives me the clusters. Okay. So ref scale let me call this and see what's there. Okay.
Oh no, it's in your own.
So let's use instead of the rev scale, this one we scale this. So let's use the rev 1. Okay. So rev 1, we are just adding the cluster points to it. Okay, so you can see here. You can see here that.
Okay.
So for each one, okay, let's view this so that you'll be able to see better. Let's name this ref 3, yeah.
Okay.
I'm for free swim. Yeah, like I didn't want to.
Greg, please mute.
All right. Okay, so let's view this. Let's view ref 3. Okay. Then we run. So you see that for each one, the original data set is the first 4. And then it has added the cluster point. So the cluster point is telling us which cluster they belongs
to.
Okay. So you can use dplyr to even filter this and just pick only those in cluster 1 and do your visualizations or even further.
Okay.
All right.
Thank you very much, Todd.
Okay, you're welcome. Please, any other question? So you're having different answers. Okay. Which ones are you having different answers? Remember that the other one, when there's somebody asked the question earlier on, it was 4 clusters, but it has been interchanged. So don't worry too much about. The main thing is that you have your 4 clusters. Yes, and you are able to interpret it. Yeah, that is the main thing. Or is it very, very different? Yes, so, but the interpretation will be the same. The values are different. Okay, I'll come and have a look at it. Okay. Please, any other question? Are you following? Hey, the way you are talking, are you sure? Okay. Okay, let's go on to do the optimal number of clusters. Then I'll come and have a look at the stuff. Okay. Okay, so we said that with K, one of the key points of K-means is that you determine beforehand the number of clusters you want to use. Okay? You determine right from the word go the number of clusters you want to use. So let's see how we can go about that. Okay, so determining the optimal number of clusters. Determining the optimal number of clusters. Let me see something. Run this one. Let me see something. This package. And then when you finish, call it in the library. It's per package. So it is used for mapping data, okay? This package is used for mapping data points. So let me make a comment here. So what we want to do is we want to create a number of clusters. We want to create a number of Ks, okay, or clusters, okay? And then based upon some parameters, we'll choose the one that is performing better, all right? So let's choose about 15 Ks, 15 clusters, and then based upon that, we will plot it, and the way the plot generates, it will show us where exactly we are going to have the optimal number of clusters. Is that okay? We call it a scree plot or an elbow plot. Okay, let me write it here. Scree plot or elbow plot. So what we want to do is to look at, we will generate a visualization. Then we'll look at the elbow of the plot. Where the elbow of the plot is where you have the optimal number of clusters. Okay, optimal number of clusters. Yeah. It's what? It's not working. It's not installed. So install it. So that's why you use the installer packages. So restart it. Okay. All right. When it says that restart, then say restart. It will just do it quickly. It will not, the whole thing will not go on. Okay. If it's not working, go to tools. Okay. What does it ask you? Update what? Yes, say yes. Say yes. Just say yes. Okay. Please, let's hurry up a bit. Okay. You spend too much time on your break. You're eating Kelly. Okay. Are you done? Please, any question? Any question? Okay, so let's quickly go through this. So let's call it from the library. So what we want to do is that we want to map 3 Ks. We have something we call total within sum of squares. Okay. When you are a bit conversant with ANOVA, you come across it. So within the clusters, okay, we're looking at like variances within the clusters. Okay. So we have what we call the total within sum of squares. Okay, so it takes how all the data, it takes the mean or the centroid, then the distances from the centroid, it looks at the differences, okay, and then squares it, just like we're looking at the Euclidean. And then so that's the total within sum of squares. And then we have one for the whole cluster. Okay, but here we are interested in total within sum of squares error. So as much as possible, we want that error to be to reduce. Okay, all right. So let's see. So we are going to have about 15 Ks. So each K will give us a total sum of square, within sum of squares error. Okay, and then we will map that. That's the reason for using this per package. All right. Yes. So it's the variability within the clusters, within each individual cluster. All right, and then we square it. Okay. All right, so let's do that. So we want the total within sum of squares. Okay, so we use the map double. Okay, and then here we're telling that we want to create 15 clusters. Okay, so 1 to 15. Okay, so we put this in a function. Just bear with me. It's a very easy function. So it will iterate. So we don't have to do it 15 times. When we put it this way, it will iterate once and then give us the 15 different cases. Okay. So let's bring, whenever you are creating a function, you put in a curly bracket. So what is our model? Our model is, let's name our model. We want to find the k-means of the ref scale. Is that not it? K-means of the ref scale. Please, when we finish, you need to go over this. So other than that, you forget everything we've done. Okay. And then the centers will be equal to the k that we have put in the function. And then it will map that with the total sum of squares. So the model will give us the total sum of squares. Okay, so we go here and then we pick it from there. In it here. Should have opened this for us. I don't know why. Function k model k means. Within sum. When you bring your dollar sign, does total within sum of squares appear? It doesn't. You should have. This one, the library. This one. No, this one is just the name. Okay. It's giving you error. We haven't run this yet. I don't know why it didn't open, but it's working though. So we've created the total within sum of squares. Let's see how, if I put it in the elbow plot, whether it's going to work. It should work. So we name this elbow data frame, okay? So we just create a data frame of our K. 1 to 15. and then we bring what we've done here. Total is equal to what is in the function, okay? Okay, so let's print the elbow plot, the elbow data frame that we've created. Hope everything works out here. Okay, good. So you see that we have the number of Ks 1 to 15 here. Yeah? Please, can you see? I will go over it because we've not done an over. This basically analysis of variances. Okay, it takes groups of data, and then you calculate. We have the total within sum of squares, the errors within a cluster, and then over the total errors for the whole number of clusters. So this one, we are just taking the total within sum of squares for each cluster. So if it is cluster 1, this is its corresponding total within squares error. Okay. If it is cluster 2, this is the total within sum. So each cluster and its own total within sum of squares. So it's just the errors squared, the differences between the mean and then the actual values. The differences that has been squared, that's all. You see, when we're doing the standardization, we took the actual number and then we deducted the mean, isn't it? Yes. This one, we are not dividing by the standard deviation. It's just the actual number and then the mean. The difference, we have squared it. And that is what we are seeing here. Is that okay? So that's all there is to it. So it's like each cluster and then its corresponding total within sum of errors. Okay? Okay, so now that we've created 15 clusters, okay, and with their corresponding total within sum of errors, let's visualize it to see the scree plot, okay? So we have, yeah. Okay, you are getting error. On which one? Yes. If you follow, have your paired package worked? Okay, so then check the syntax well. So you, please, it ends in 98, oh, the curly bracket and then the bracket. It starts from here to here, the function. Okay. So add that, make sure that when you run it, it's also even where I put the visualize is wrong. Let me just remove this. Probably bring this up a bit. So let's visualize it. So we can do that using our normal ggplot. Okay. So library, let's call the library ggplot. Please, Kumasi, are we okay? Hello?
And now we are here.
Okay. All right, so let's ggplot our elbow data
Yes,
frame.
sir.
Elbow data frame. Okay. And then our aesthetics, our X will be the K, and then the Y will be the total within square. Okay. So our X is equal to K, all right? And then our Y is equal to total within, so let me just, within sum of squares. Okay, so we are adding a geom line and then a geom point. So a geom line plus geom point. Okay, let's add another layer to it so that it will give us the bricks on the x-axis. Okay, so let's use our scale underscore x continuous. Okay, this one. So here we specify it to give us bricks of 15. Okay, so let's run this. Okay, so you see the elbow plot. So this is our elbow plot. So where there is an elbow in the plot, you see, so for this one is supposed to give us the bricks up to 1 to 15. Okay, sorry. Let me make this 1 to 15 so that we can see the clusters. Let me run this again. Okay, so on the x-axis, you can see the clusters from cluster 1 to cluster 15. Okay, and then on the y-axis is where you have the total within sum of squares error. All right, so as much as possible, you want to reduce the total, you want to reduce the errors, isn't it? So where the error gives you the least is really something you want to work with. So you see that after the first cluster, the error reduces significantly. Please, are you following? So you see that the second cluster is where the error is below 1,200. Have you seen? Now, on the third cluster, it reduces even further. Okay. Now, on the fourth cluster, here, you see that it is reducing. So normally, we find where the elbow is. Here, you cannot see so much, but at least you can see that the fourth cluster, then it begins to slant a bit. All right. So this gives you an idea that we should use 4 clusters for the k-means. Sometimes when you do it, it's so visible. You can see the elbow. Okay. So from that point going, though the sum of squares will be reducing, it's not going to add any significant thing to the data. The error is significant. So we stop at where the elbow is. So that's why we call this elbow plot or scree plot. Okay, so where the elbow is the optimal number of clusters you should use. So it's not every time, okay, I'm doing k-means, do 3 clusters. No. First of all, so based upon what we did, probably if you were versed in this already, probably this is the first thing we would do. Have you seen? And then we'll have an idea as to the number of clusters we should use for our k-means. So now when we go back to our k-means, did we use 3 or 4? We used 4. Okay. So that's fine. Is to find the optimal k. Yes. In the yes. That's why I'm saying that some people just use the square root of the number of data points you have. So if you have, let's say, 50 data points, they will just find the square root of 50. The number that they get is what they use as the K. Remember, if you don't use the optimal K, there are some insights you might miss. So let's say you use 3, but probably the optimal K was 7. So if you use 3, you might get some insight, but you wouldn't have gotten more insight should you have used 7. So that is why getting your optimal K is important. Total within, yeah. Nancy, I'll be with you in a minute. Yeah. This one. Which one? Which line? Yes. Okay, so here, the first one is just the name we have given to the function. Okay, we've not done functions though, but the reason for doing this is that we could have done this one after the other 15 times. But instead of doing it 15 times, we created a function using the pair package that it should calculate 15 clusters for us at the same time. So it's going to give us 15 clusters and also 15 for each cluster. It's going to give us, how do you call it? Total sum of squares error. Oh, we just chose 50. You could have made it 20. So you could have made it 20 and then still find the optimal, it will still give you 4. Have you seen? You could have chosen 100. Then it will still work out to give you the optimal number of clusters. Okay. But be realistic. You don't want to have so many clusters. Okay. Yeah, so here, the function is to give us 15 Ks. Okay, 15 cluster centers. And then for each one of them, it should give us the total within sum of squares. So what it's doing here is that it is mapping each cluster with its corresponding sum of squares. That is what this map DBL is about. It maps data together. Okay, so that's why here, if you see here, we are able to get the K and its corresponding total within sum of squares. If you look at the console right now. Okay, so this is the output of the model that we created. So for each K, it's giving us its corresponding total within sum of squares. All right? Yeah. Yes. So we took all the total within sum of squares, okay, and then created a data frame 1 to 15 for the K, just for the K to show 1 to 15, all right, and then corresponding total within sum of squares. That's it. Yeah. This one. Like this. Okay. So this is just the name. This is just the name we are using for the data frame. That's why you have the name here. Okay. That's why we are using the name. And the name is equal to what we use in the function. All right. Yeah. It's not showing. Did you do the ggplot well? Is it giving you an error? Okay, have you clicked on plots? Are you on plots? Nothing is coming at all. Which previous one? The previous plus is what you have. Okay, I'll come and have a look at it. Okay, so okay. Yeah, yeah. All right. Just save issue. What save issue? Okay. But now, see what you see all this means that there are errors in your code. Okay. So did you install the problem? Okay, that's what I like. Right? That's university. What we are talking about, because I've seen Yeah. Please, are we okay? Okay. Right. Let's go on to hierarchical clustering quickly. Yes. Nicholas.
Yes. So when I run my error.
Yes. When you run it.
Yeah, it was an error.
Okay. Which part did you get the error? Is it for the elbow plot? Or
Yeah,
where?
for the elbow plot.
Okay, let's have a look at it.
This that.
Okay. Let me see the error you are having.
Yes.
K means. Okay. Did you run the library? Run the library for the pair LSC. Okay, so your library is good. Okay, run the, let me see the K is the function you've used capital K instead of small k. Okay, so run it again. Run line 72 to 75. Yeah. So run your elbow. Good. Okay. Okay. So that's about it for hey, this thing. How can we go back to the PowerPoint in the presentation mode? Nancy, were you asking a question?
Yes, Doc.
Oh, please go ahead.
Thank you. Doc, I beg you, could you explain again why 4 is the optimal?
Okay, no problem. Can you see my R Studio?
Yes, Doc.
Okay, so you see, this one is not showing properly, but it's still there. So what we've done is that for each K, we have calculated the total within sum of squares error.
Yes.
All right. Okay. So you see that for the first cluster, the error was over 1,600.
Yes.
Isn't it? Okay.
High. Yes.
Very high. And then it reduced significantly when we came to the second cluster.
Yes, to about 1,000.
To about 1,000. Good. And then the third cluster is about 600 or something. Now the fourth cluster, let's say about 500, a little over 500. Okay. Now, sometimes you will see the elbow like a normal elbow. You see the way you have your elbow.
Yes.
So
right where it bend begins.
Where it bends, exactly. So from that point onwards, though there might be errors there, that is decreasing, but it is very irrelevant. Okay, so you want a place where after the significant falls in the errors, it becomes kind of steady.
Okay, Doug, is it the proportion of the decrease?
No, we are not looking at the proportion of the decrease. Here, we are just looking at, okay, you can put it that way. So, so from the elbow, from the point where you have the elbow onwards, there might be slight decreases in errors, but it is not anything that will impact your So this one is not, you are not seeing the elbow properly, but in some other plots, you will really see it like an elbow, and then the rest are very insignificant.
So, Doug, it's like the last point where we have the most drastic fall in the error. That would be the optimal.
Yes, basically something like that. So look out for the elbow, where you have the elbow.
Thank you very much, sir.
Okay, all right, you're welcome. Yes, Yao.
Doc, following up on her question. So when we were doing the individual calculation, we realized that when K became constant, the number wasn't changed. That's when it was quite like the iteration stopped. So I thought within the elbow, when it becomes a little bit stagnant, like around the 7 area, that's where you can pick your K mean. Wouldn't that be optimal around that area?
Where
I was thinking the same. Like around
7. Where it flattens out.
Where it flattens out. Okay.
Yes.
Yeah.
No,
initially that was what I was thinking.
Yeah, if you have to use 7, you will not be wrong.
Okay.
If you have to use 7, no. If you have to use 7, you will not be wrong. Remember that we want the optima. So if you look at the script plot, let's look at the one for this one is 352, isn't it? And then the 4 is 544. 544. Okay. But at 7, you are not really seeing the elbow, So that's why I settled on 4.
Okay.
All right.
Okay.
Doc, please, one more question. You said that we could even iterate over like 100 to find the optimal. So if we are going through 100 variables,
By 100, I mean,
can it
practically,
ever
that's the thing. Practically, how will you plot it on a GG plot? So you just want, so you want an optimal number. So there's no need to create.
Make it so large.
Exactly. Why do
I was
100?
thinking with 100. I mean, could it be just
Yeah, somebody might even
can...
say 1,000.
All
okay.
right.
Okay. It's just for you to know that you can pick any number and then check it. All right. All right. Yes, Christiana.
Please, they've asked the same question.
They asked the same question. Okay.
I wanted it to be at 5.
You wanted it to be at 5
instead of a 4.
Okay, that's okay. But as much as possible, this one didn't come out very well. But in other pro, you really see the elbow. Okay, so that is where you pick it up. Why are you removing the point? The curve. Okay, so you can remove the point. That's fine. So you just have to remove the jump point, and then it will just do the line. All right. Okay. So now no break. We are going straight away. We'll spend so much time. Please, how can we do the, and then quickly, let's do this. It's a cluster ninja, Yeah, so what do we do? You have to stop the sharing. Okay, stop sharing. Oh, just you say you pause this. So just stop it. So stop. Yeah, stop it. You forgot how you did it. When we finish, we'll discuss the assignment. But today is our last class. You have to present assignment 40% of your marks. You say for this model. Next week we are starting another model. You say no, not in groups. This is data science.
Please, which assignment?
Yes, we'll discuss it very soon. Okay. Christiana, we'll discuss it very soon. Okay. Is it working? Okay. Okay, so we've dealt with k-means. Okay, so let's go on to hierarchical clustering. Kumasi, please, are you following?
Yes, dog.
Okay, so with hierarchical clustering, here we don't know the clusters ahead of time, unlike k-means. So with k-means, you specify the classes ahead of time. Okay, but with hierarchical clustering, we don't know. Okay, so we are now going to find out. Now we have two main types of hierarchical clustering. That's the bottom up or the top down. Okay, bottom up or the top down. So it builds from the top, from the bottom up, it builds from downwards, and then it subsumes other classes. So at the bottom, it creates so many clusters. As you go higher up, other classes take on other clusters. Okay, higher up, it takes on other clusters. Then you become to the point that you have one whole cluster. So if it is top bottom, it starts with one cluster. Then as you come down, it divides into other clusters. All right? Okay. So that's the agglomerative and the divisive. All right? So here, the process involves assigning every point to a unique cluster. Yes. Yes. Yeah, you have so many clusters. Okay. So we'll be delving more into the agglomerative, the bottom up. Okay. So it computes the distance between all clusters. Remember Euclidean distance. Okay. And then finds the closest clusters and merge them into one cluster. Okay. It recomputes the distance of the new cluster with all other clusters and repeats 3 and 4 until we have one cluster. Okay. So it's very intuitive. So a typical dendrogram. So a dendrogram is the visuals for the hierarchical clustering. Okay, it's similar to similar to decision tree, but it's not a decision tree. We call it a dendrogram. Okay. So I will explain what we have here. So at the bottom here, okay, at the bottom here, where I have my cursor, these are clusters. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it 9? So we have 9 clusters at the very bottom. Okay. So you see that these first 2 clusters are subsumed into this one. Have you seen? Okay. And then these 2 are also subsumed into this one. Now, these 3 clusters, 1, 2, 3, are also subsumed into that one. Okay. And it goes on and on until you have one cluster. Okay. So that's how it works. So let's say you have typical data points here. Okay. So the first one, have you seen the cluster? So it has joined 11, 4, and 12, 3 points. So this, I'm talking about locations. So 11, 4, and then 12, 3. And then the middle point is the clustroid. That is you add the 2 and divide by 2. Okay? So it gives you the mean or the clustroid of that cluster. Please, are you following? Then it is subsumed into the other cluster. So this other cluster is nearer that cluster. So it creates a bigger cluster. So now you have 3 main points. You add them, and then the centroid will now change, isn't it? It's going to be 10 and 5 plus what? 12 and 3, and then 11 and 4. Okay, and then it creates another centroid. All right. So it starts from the bottom with clusters, and then another cluster will subsume into a bigger cluster. Okay, and it goes on. All right. So you see that now we have 3 main clusters, but within these clusters, there are smaller clusters. All right. There are smaller clusters. Okay. And then you end up with a dendrogram. So it subsumes them, and then you have one big cluster. Okay. Any questions on this? So we'll see how this one works in R. Okay. So let's take. Yes.
Another question. After the first clustering calculation for the centroid, does the next
after
cluster,
the first calculation,
for the centroid, does the next one uses the centroid and the other cluster, or use the 2 clusters?
No,
with
so after the first one, the next one, it comes to add the other data points to the or existing 2 points there. So now the centroid will comprise the 3 data points, not 2 anymore.
Okay.
Have you seen? Okay.
Yes. Thank you.
So all the centroids you are seeing now. So like this one is just this plus this, and then you find the mean. It gives you the centroid. So if there are 3 elements within the cluster, then you add all the 3 and then find the centroid. If there are 4, add all the 4, find the centroid. Okay. Remember, they are in coordinates. So if it is SY, add all the SSS together, find a centroid, and then YYY together, find a centroid. Okay. So if there are 5 clusters in a bigger cluster, that means you are going to add what? 5 data points and then find the centroid. All right.
Okay, thank you.
Good, good. So now let's go to R and then see how we can practicalize this. Okay. Are you seeing my R studio?
No,
No,
Master,
please.
you're not seeing it. Okay. So let's see how we can run with our hierarchical clustering. You remember the clusters that we did for 3 players? Was it for 3 players? Let's create another one.
It was 2 and 3.
2 and 3. It was just 2 and 3, yeah? Okay. Okay. So let's create another one quickly. X. Oh, let me make a comment to this hierarchical clustering, yeah? So S, let's create a vector. So -1, we are just creating coordinates. -2, 8, 7, -12. And then -15. Yeah. So that's 1, 2, 3, 4, 5, 6. Okay. Let's do that for Y. See, that's 1, 3, 6, -8, 8, and then 0. Okay. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So let's run this. Okay. So now let's put them together, okay, into XY. So let's create a data frame and call these players. So this is the position of players, okay? So we create a data frame. And then we put X and Y together. Okay. So when we call players, it should give us the combination of the X and Y. Yeah? Let's move this up a bit. So once we've created this, then what do? We determine the distance. Do you remember? Okay, so let's determine the distance. So the distance between the players. Okay, so this, the distance of the players. So we use a dist function. Yeah, remember? And then we are using it on the players. Okay. And then the method is what? Euclidean. Okay, because this is numeric. This is what we did in the morning. Okay. Okay. So let's run it. So when you find the distance, this should give us the distance among the players. Okay. So that's calculated various distances among the players. Okay. So now let's create how do you call it? The hierarchical clustering. Okay. So let's say HC players. So the function for the hierarchical clustering is H class. Okay. So it looks at the distance. Okay. So what we've done here. So the first argument is the distance. Okay. And then you specify the method. I will explain this very soon. So the method here is complete. Now, when we run this, okay, the hierarchical clustering has been, the model has been created. So now let's plot it, okay, and then you see it in the dendrogram. So visualizing the dendrogram. So plot HC players. Okay. Okay. So you are seeing the cluster dendrogram. Okay. Now, these lines that you are seeing here extend downwards. Okay. They extend downwards. All right. They extend downwards. Now, let me explain the dendrogram. On your left hand side, you see the height. Please, do you see? On the left hand side. This is the Euclidean distance. Okay. The height is the Euclidean distance. So at Euclidean distance 0, okay, if you are to draw a horizontal line through here like this, okay, you are going to have how many clusters? Supposing this one comes here, this one comes there, yeah, they go down, all right? They're going to have 1, 2, 3, 4, 5, 6 clusters. So even at a Euclidean distance 1, I'm sure you get 6 clusters, okay? Now, when the distance increase, okay, so if the Euclidean distance becomes 2, becomes 5, let's say we draw a horizontal line, okay, across like this, okay, then it's going to pass through cluster 5, isn't it? It's going to pass through cluster 6. It's going to pass through cluster 4. It's going to pass through cluster 3. Now, cluster 1 and 2 has become 1 now. So at Euclidean distance 5, you are going to have how many clusters? 5. All right. Now, if you go up higher, Euclidean distance 15. Where do you think, how many clusters are you going to have?
1.
2. Have you seen? So you see, as the Euclidean distance increases, it gets to a point you have only 1 cluster. Okay, so they are in hierarchies. They are in hierarchies. That's why we call it a hierarchical clustering. So at the very bottom, you have so many clusters. As the Euclidean distance increases, okay, the clusters become smaller. Okay, the distance. So now you are not getting the homogeneity that you might need if they were very similar. If they were very similar, then you have so many groups. Have you seen? All right. But as they become more dissimilar, as the Euclidean distance increases, all right. Now it is much more broader. Okay, your clusters becomes much more broader. So that's why it's important to know the optimal number of clusters so that you'll be able to check and not miss any insight of your data. Okay. Any questions on? Or you can use both of them. You say, you see this one gives you the hierarchies. K-means does not give you hierarchies. Okay, so depending upon what you are doing. Okay. In what instance is? Okay, supposing you want to find out segregations or subsets within your data. Okay, subsets within your data, then a hierarchical clustering might help. Okay, if you want to find out segregations or subsets within your data, hierarchies within your data, then hierarchical clustering might be of help to you. Have you seen? But if you just need the data coming together in groups, but not hierarchies within the groups, then K-means so broader market segmentation, both hierarchical clustering and then K-means might help. But let's say you want to find out, okay, this particular area, how are there hierarchies within this particular market segment? Have you seen? For instance, you can have a market data that relates to Accra, that relates to region, that relates to country, that relates to, you see those kind of hierarchies. All right. So you have data, you have education. You want to group it from lower and higher education. That means you already know what you are looking for.
Maybe you have a data.
Or it depends. It depends upon how the cluster is. So let me repeat it so that those in Kumasi will hear. So if you want a data set you have a data set on education and you want to do clustering, okay, how do you, okay, so the clusters will have so many features, isn't it? So if it is, it will tell you, let's say, it can tell you the level, it can tell you the type of student, it can, all this information, okay? What you do is that, first of all, you need to standardize the data, clean it, and then standardize it. After you standardize it, then you can determine that, okay, I want to see 3 clusters or I want to see 4 clusters. Let's assume that you've determined your optimal number of clusters, okay? You can use K-means to do it, okay? And then it will give you the clusters. However, you can also use hierarchical clustering Okay, and it also gives you that this one is in cluster 1, this one is in cluster 2, just like the k-means. All right, but with the hierarchical clustering, it tells you that, okay, cluster 1 and 2, okay, let's say they've been grouped, okay, they go into cluster 3. Cluster 3 is this. So there's, okay, these people, I think there's some vertical hierarchies between them. So that hierarchical clustering will give you that insight, whilst k-means will not. Okay. So this one gives you added insight, kind of. All right. Whilst k-means will not give you the hierarchies within the groups. Okay. Yeah, any other question? Any other question? And before you go on, remember that I said that I'll come back. The method that we have here, the complete. Okay, the complete method that we have here. Now, if you go to what we have calculated here, the distances between the clusters, okay? Let's say we are checking on cluster 1 and 2. The distance is 2.2, okay? Which one is the closest cluster to 2 and 1? Which other cluster is the closest to 2 and 1? Kumase, you can also answer. Which one is the closest to, which other cluster is closest to cluster 2 and 1?
6 and 5.
What?
5 and 6.
5 and 6. Okay, 5 and 6 is 8 points. Why? Hey, my data scientist, everybody is quiet. Yes. So I'm asking him, or you could also answer. He is saying that cluster 2 and 1, the distance is 2.2. And I'm asking that, what is the next closest distance to cluster 1 and 2? The 5 and 6. Well, the answer is that you don't have enough data. You don't have it. It depends upon what you are doing. All right. So that's why this method of complete comes in. Now, the complete, it depends upon how you want your cluster to be. So the complete method, what it does is that it takes the clusters that are furthest away. Because you see, we saw some other clusters where they were overlapping. Do you remember? Some of the classes were in some clusters. But if you want to create distinct clusters, one of the ways to go about it is to use the furthest distance to create the cluster. So when you specify on complete, what it does is that it takes the furthest cluster in creating the clusters between the two. Okay. And then we have, so that is the complete. And then we have another one called, let me just make comments here. So cluster distances. So we have the complete. It takes the maximum distance between points. Okay. So it takes the maximum distance between clusters. All right. And then we have the single. So all this, we call them linkage methods. Okay. So the complete is a complete linkage. Okay. So make linkage methods. So the complete takes the maximum distance. The single takes where you are interested in the minimum distance. Have you seen? It takes the minimum distance of data points to create the cluster. Okay, so this one it takes minimum distance. And then we have the average linkage. As the name goes, it takes the average. Okay, so it's in between maximum and then minimum. So probably I was a bit unfair in asking you the closest distance between 1 and 2. So by default, hierarchical classroom will do the complete. Okay, even if I don't bring the complete, it will do the complete. Okay, so probably a fairer question to you would have been that based upon the complete linkage, which data point is nearest to 2 and 1? So now you can answer. Based upon the complete linkage, which data point is nearest to 2 and 1? Which other cluster? Which other pair of cluster is nearer to 2 and 1?
I also want to say 5 and 6.
5
and 6.
Oh no, if we are using the complete. If we are using the complete
linkage,
then we are looking at the maximum distance. So in this case, if I ask you, taking the maximum distance into consideration, okay, or using the complete linkage, what is the closest pair of cluster to 2 and 1? It will be 4. No. Why 4 and 5? What about 3 and 6? Oh, 4 and 5 is 24. Oh, okay,
yes.
Okay. Sorry. So 4 and 5, sorry. 4 and 5, so that is the one with the maximum distance. So in this case, it is the closest. All right. So if we were to use single linkage, what is the closest pair of cluster to 1 and 2?
5 and 6.
That is where 5 and 6 will come in.
Yes, dog.
Okay, so it depends upon what you are doing. That will determine whether it is a single linkage or, maximum. All right. Okay. So normally, when you have outliers within the data set, okay, then you are better off using the minimum. Okay, so that the outliers will be seen. All right. So if you have very huge numbers within a data set, then it's better to use the minimum, the single linkage, so that the outliers will not come and distort your clusters. But if you take the maximum, it will go and pick the outlier and then bring it into your cluster. Have you seen? All right. So those are some of the ways by which you can avoid noise in your clusters. Okay. So here, lastly, let's quickly take the lineup data set that I sent to you. And then let's create. So practical example 4. Let's take the lineup. Yes, Christiana.
Please, the last graph we plotted, the plot H, mine is giving me the margin is too large.
No, so have you I don't know, but create enough room for your plots to show. Move your plots. This one's. It's okay. So they were moving, move it so for it to have enough room for it to plot.
Okay. So I've given it the space, but it's not.
Okay, let me have a look. So let's look at 4. So import your lineup. So the extension is RDS, okay? So read it with read RDS. The RDS capital R. I'll come back. Let me sort out Christiana first.
Please, sir, can you say it?
Just a minute. Okay. So you've created, okay, so run line 9, let me see. So that's running fine. Okay. Okay, run 10. Okay, good. All right, so create the hierarchical class model. Okay, so plot it. Yeah, it has plotted.
The magic about you when the same thing I'm doing. Thank you very much.
Okay, all right. All right. Okay. Oh, where is my share? I can't see it. I can't see how I can share it. Please, can somebody help me? I can't see the where I can share it. Where? Where? Okay, okay, okay. Thank you. All right, so let's bring the let's read the RDS. So you read just like you read CSV, okay? So read RDS, okay? The extension is RDS, okay? And the is lineup.rds, okay? So this is another format. So let's name this lineup. Yeah. Let's run this. So let's plot a distance matrix, okay? Okay, so we have our dist lineup. So we use our dist function on the lineup, yeah? So when we call this, it should give us the Euclidean distance for all the okay. So we have that up to 12, okay? No, I've just done the distance. Okay, so one thing I will tell you is that by normally with a distance we said that was Euclidean. So by default, if you don't show it, it will still calculate it Euclidean. But if you want it to show Jacquard, then you have to specify that it's binary. Okay. So that's the default. So let's see the difference. So here, prepare, or let's say generate. So generate hierarchical clustering, H class for complete single and average linkage methods. So we can do HC complete. So here we are looking at the maximum distance, isn't it? So it will prepare hierarchical clusters based upon the maximum distance, all right? So here H class, and then we take our dist lineup. Yeah. We take our dist lineup. That's for the distance. And then the method will be complete, yeah? Method is equal to complete. Yeah? Let's run it. Let's do for single and then average. So just copy this whole thing, okay? You don't need to write it again. Basically, let's make some changes here. So let's do for single. Let's change this to single. And then we change the method to single, yeah? Let's run this one too. And then let's run it for the average. I want you to see the differences. Okay, so this one is average. Then we change the method to average. Let's run this one too. Okay. So now let's plot the three of them. I want us to plot it side by side so that you can see the difference between them. Okay. Side by side, okay? So first of all, we use it normally when you want to see multiple, it's similar to the facet wrap. Okay, when you want to see multiple visualizations, and we use the power function, it partitions it. Okay, so we use power function, power m through. So it looks at the multiple rows. Okay, it's equal to one visualization but three plots. So 1 and 3. Okay. So once you do that, any plot that comes, it will put them together. Okay. So let's plot all the three. So plot HC complete. Okay, and then give it the title complete linkage. Okay. let's do the same for the other two. We plot them together. So this one will be HC single, yeah? So this one will be single, the heading will be single linkage. And then we plot another one. That is the average. So this average linkage. So let's plot all these three. Okay, let me increase it a bit so that you see. Okay. So you see that the complete gives you, distinct clusters. You are able to see all this. So the complete, this one takes the maximum clusters. So if you want to see more distinct clusters, use the complete linkage. Okay. Now you have the single linkage. This one takes the minimum. You see the difference. So you see that on the left-hand side, this one just has 2 clusters, the single linkage. Whilst on the complete linkage, it has about 1, 2, 3, 4, 5, about 6 clusters. Okay. When you take the average, it has a bit more clusters on the left-hand side than the single. Okay, because it's in between the average and then the single. Okay. So depending on what you are doing, choose complete, single, or average. Okay. If you have a lot of outliers, use the single so that the outlier doesn't come to, disturb your clusters. Yeah. Any question? Yes. So remember last week we did the box plot. Okay, and the data points on the above the upper whisker are all outliers. So one of the ways you can find the outliers is use your box plot, and then you'll be able to identify your outliers. So when you identify them, you decide what to do, whether to eliminate them or to replace them with the mean. It depends upon what you are doing. If you add them to the mean and it's going to disturb you, then probably use your median. Okay, use your median. Don't rely on your means to make decisions. Rather, use your median if you have very huge outliers. So one thing you could do is to remove the outlier, or you can replace it with the median or something. So it depends, that's what I'm saying, it depends upon the kind of data you have. Sometimes it is good to keep the outlier so that you can put things into perspective. Okay, other times too, they are just noise and you just have to remove them. But as much as possible, replace them with the mean. The mean without the outlier, have you seen? Don't add the outlier and then come and use that mean. So it's the mean without the outlier, replace it with that. And that's also. Yes. Have you seen? Because if you add the outlier and then calculate the mean will be way off. Okay. All right. Any questions? The code for the linkage. Okay, it's here. I should go up a bit. $134. Okay. Like this. 131. Okay. So that's where I read the lineup. Yeah, so you use the read RDS to read the data because the extension is not CSV. So you can't use normal CSV to read it. So that's why we use the RDS. When you read it, are you sure? Okay. So you can't read the file, but others have read it. Did you read yours? You have it in that where you set your working directory. Is it where you are taking it from? Or is it down? Let me check this working directory. That's where we started. That's the working directory. Okay. Where you have the set document. Where you have the set. No. So how do you do it? How do you report? So the ones. So is that where your data is? So copy this and then web. So if you look, not who are where your data is stored. So copy it and then run it. Then it will go into that directory to take the line up. Okay. Is it working now? Okay, Kumasi, are we okay? Are we okay, Kumasi?
Yes, dog.
Okay.
No,
good,
dog.
good. All right. What's the issue?
So I'm getting some errors.
What are the errors?
Okay. The error in G file cannot open the connection.
It's the same. So check your directory. Did you set your working directory? The set
No.
W. Did you set it whilst we are working today?
Yeah, I did.
Okay. Is that the same place where you put the line up data?
No, a different file.
So if you've put in a different file, then R is still working with the old directory. So
Okay.
go and put it in the where you set your working directory.
All right.
Unless you want to change it. If you want to change it, you can go to if you want to change it, you can go to session. Okay. You can go to session, set directory, and then choose where it is now so that it will change it for you. Other than that, the one you have set is where it will work from.
Okay.
Yeah? Okay. Are we okay? You seem happy. Oh, I'm happy. I'm glad. What's your name? Edwin. Okay. Edwin and Bridget. Okay. So now I know the Accra people. Yes, Felicia. Felicia, you've raised your hand.
Sir, please, can you move upwards for me?
Okay, okay, no problem. To what line?
Okay, no, downwards rather, sorry.
Downwards.
The plot.
Okay.
Okay, thank you, sir.
Okay, please, let me remind you, when you partition it this way, okay? When you partition it this way, and then you leave it like that, other plots that you will do, it will show this way. So when you are done, okay, I'll know that you are done with the partitioning, okay? So this power function here, okay, please pay attention. This power function here, change it to 1, 1. So it will show one visualization in one plot, okay? Other than that, you'll be seeing the other one. All right. So let me make a comment here. Shows one visualization per plot. And this one shows 3 visualizations per plot. Okay. Okay, Felicia, yeah. Your hand is still raised. Okay. Can we discuss the assignment? You're being baptized with data science stuff, eh? It's good. Now, when you see Excel, you see that it's kid stuff. Okay. Let me know when you are done, then we discuss the assignment. Hands up. Okay, Christiana, please. How can I help?
Please, mine is not working. No.
Which one is not working? The
After yes, you see.
Oh, is that so?
Can I show you my?
Yes, yeah. Why are they treating you like that? Please share. Please, Christiana, share. Yes.
Please, I'm coming on. Please, I'm coming.
Okay. Oh no, take your time. The best way to learn the thing is to get your hands.
Please, you see the first start.
Yeah.
The practical example.
Just a minute. Yes. So yeah. So you set. So Christian, what happens is that line 24. You see, when we started, we set a working directory. Okay. So everywhere, all the places that you've put your data in, as long as you set your working directory and you are working from there, you just need to call that thing once. Your set working directory. Just run it once. Once everything is in that directory, when you call it, it will come. You don't need to call it every time you are importing data, unless the directory changes or you.
Can I ask a question? If I understand what you are saying.
Yeah.
If I have a folder and I have all my data in it, once I open one from there, the rest, I don't need to call it again.
Yes, in a particular R session. So let's say today, when we started, you set your working directory, okay? you gave it the location. So far as all your data sets are in that location, you don't need to open set working directory anytime you are importing data from that particular location, unless the location has changed.
Okay.
But if you do it severally, it will still work. But what I'm saying is that it is unnecessary work.
But in this case, they are all in the same directory.
Yes. So the point I'm making to you is that you don't need to bring it again.
Okay.
If you are just going straight to line up read RDS, it would have come.
Really?
Yeah.
But
Yeah, you did the same and it was still the same.
it's still not working. I
So
just brought
because yes, because you have saved it in another file. The lineup is not in the same place where you have your set working directory.
Actually, it's in two places. One is
And that's what I'm telling you. So if it's in two places, if you want to set a new directory, two things. Either you can go and take your lineup and come and put it in this place in line 24, where you have that direct path, or you want to change it. If you want to change it, then fine. Then go to sessions. Go to sessions at the top.
Section, please. Where's the okay. New section.
And then see set working directory.
Okay.
And then choose directory, and then navigate to where that data is, the lineup is. So navigate, so you see that the original thing is not here. So navigate to where you have the lineup. Where have you stored it?
It's in two places. It's not.
So when you are able to identify it, you'll be able to read it, okay? Okay, guys, can we discuss the assignments?
Yes, sir.
If you're okay, please put your hands down, okay? Christiana. Thank you. Okay. Let me see if I have the assignment here. Okay. Let's check. Okay, so this is the assignment. So select any peer-reviewed journal topic of your choice and find a suitable data set that is related to the chosen topic. Perform an exploratory data analysis to discover patterns and hidden insights using any of the process models in data science. Provide a summary of the journal article and incorporate results of your EDA accordingly. So your work should include at least 7 references, not more than 5 years old. So send me this, a copy of the original peer review article, okay? Metadata on the data set, including the source of your data. All your R codes should be within the RStudio IDE, okay? And then you should Your summary should be in a Word document consist of at least 3 pages, excluding your quotes and then your reference list. Okay, so submit to this email address, 17th March. You can take as long as you want to do it. Okay, but 1 week after the deadline, 10 marks deducted. 2 weeks after, 15 marks deducted. 3 weeks, 20 marks. Beyond 3 weeks, it will not be accepted. Okay, so this constitutes 40% of your work, and then the exams is 60%. So try and make it big here. So let me just explain what I mean. So take any peer review. That means that 2 people cannot have the same work. Okay. So take any peer review, any topic that you are interested in. Okay, I see you have some interesting data using Power BI. I don't know. You might be interested in, let's say, COVID. Somebody might be interested in airline, flight delay, whatever. So find a peer review journal on that. And then based upon that, okay, find a data set in that area. Have you seen? Do your EDA. Summarize the peer review journal. And if your EDA gives you further insights, add it to your stuff. Yes. So that's the main point. Don't just summarize you're just summarizing the peer review journal and bringing it to me. No. That's why you have to do your EDA and then incorporate any further insight you might come across. Just a minute. Go ahead. So impact of consumer behavior. Can you find a data set in that area? So find something that you can give me data set. Go to Kaggle, GitHub. There are so many areas, please, thousands of areas that you have data set. Go and find the corresponding an article in that area, and then just do your work. All right. Okay. So whatever area you choose is fine by me. So far as you can get your data set in that area. Okay. Summarize the data, summarize the whatever you've learned from that article and what new things you are getting from your data in that area. Put it together. Let's have it, and then we are ready to roll. I'm not saying only you can get so many places. You can go to data.gov. It's a US. They have. Francis, I'll be with you. No, just give me an article area. Okay, you find an article. Just concentrate on what that person has. The article that you've seen. The broader the article, the less difficult, the more difficult the thing will be. So just get some specific area and then some specific data to go with it. Let's say COVID-19. There are so many areas in COVID-19. Okay, so you can get an article in a particular area in COVID-19. Get some data on COVID-19. Let's go. Yeah. Okay. Yeah. No. I don't want you to go to that area. All that I want is that the thing is in COVID-19, you know, the area that the person did the thing. Okay. All right. Just find a data set. It might not be exact, okay, but in the same area. What are the key things you are picking from that article? Okay, and then what are the things that your new data can add to that insight you've gotten? That's all. Okay, so you can go from there and then give me what you can get from your article. I don't want you to just go and pick any data. I want it to be informed. All right. Okay, so if you are picking, let's say, data on air travel delays, for instance. Okay, there are so many people who have written on that. Okay, there's so much data on air passenger delays. Okay, pick, you don't have to pick the whole data. You can just, if it satisfies the 1,000 rules, you can just pick a subset of that data and then do your ED and then yeah, so whatever you can do, just new insight in that area. I'm not asking you to go and do somebody's research again for the person. Okay, just find a data set in the area that your peer review journal topic is about. Is that okay? I'm not asking you to disprove somebody's findings or whatever. No. You are not doing the work again. All right. I've given you a criteria of 1,000 rows. At least. Yeah. Okay. So whatever area you want to, but I want it to be informed. Don't just pick a data set from anywhere and then you bring it, that you go and pick something that somebody has done in Kaggle and then you bring the code to me. I will see. Remember, I've been in this thing for a long time. So if you do that, fine. But I will see that, the main point is to bring that, let the data science spirit in you come out. All right. If you go and copy and paste, I will see. Do you think I will not see? I will see. Okay. Yeah. Yeah. You might even take the same data set, but as for the peer review journal, I don't think it's going to be the same. Surprisingly. Okay. All right. There will be what? Yeah. So surprisingly, all your names, your data names, everything is the same. Hey, there you are, wild though. Okay. Please, Kumasi, are we okay with the assignment? So I'll put everything on the platform for you, or I'll send it to Ransford to distribute. Please, if you haven't filled the Google form, I'm the one who requested for your email and stuff like that. So that as soon as I get, I start marking. All right. So please make sure that Ransford gets everything this evening. So that as soon as I get your work, I'll know who you are and everything. Okay. Thank you very much. Kumasi, are we okay?
Yes, please. Can you please scroll down a bit so we get the further instruction?
Yeah. Everything is here. I will send this to you. I'll give it to Ransford. I'm not sure Ransford is here today, is he?
No, please. Today's tutorials, when are we going to have it?
What tutorials? We are not, after all we've done,
today's
there's
class.
No tutorials. So.
I mean today's class.
What class?
I think
today
he means the
recording.
The recording, I'm not the one who recorded it. So I think two of your colleagues recorded it. So please get it from them.
Okay. All right.
Oh, I get you now. You mean the recording. Okay.
Yes.
I think it's the recording and the slides, I think.
Yes, so I will send, as for the slides and everything I've done, I will send it to Ransford, you should get it.
Okay. Thank you, sir.
You are welcome. So it's been a short but very insightful journey. Okay, so I will meet you on mathematical foundations for data analytics.
Okay.
I'll see you on the other side, on the next block. Okay.
Please, I have a question.
Yes, Felicia, please go ahead.
Hello, sir.
Yes, Felicia, go ahead.
I want to find out whether we can contact you anytime the need be.
Oh, yes. But you are not contacting me, sorry, to do your work for you.
Oh, no, sir.
Definitely. If you are stuck on something, just let me know and then I'll help.
Okay, thank you.
Okay. Please, are we okay? All right. So it's been a long day.
Please, my hand is up.
Christiana, yes.
Please, I want to find out, in case you are working on or you haven't saved it and by mistake you shut the machine off, how will you retrieve your information?
Wow, that's difficult. So as much as possible, as you are working, be saving as you go along, okay?
Then I lost today's work, everything.
Don't worry, I'll send you the slides and then the scripts that I've used.
Thank you, sir.
Any other question? Okay, guys, thank you very much. Have a lovely weekend. So I will hear from you soon. Okay, all right.
Take care.
Take care. Bye. Please come for your what do you call it? Come for your device, okay? It's really nice. Is it expensive? Oh, okay. I'll get some. Thanks.
Please, sir.
A combo. Chromebook, okay.